Once your mensuration chapter is over, there is not going to be much left for your math syllabus. So I want you all to revise the chapters that have been taught already very thoroughly. Okay. Okay, now next portion of your exercise, next portion of your chapter of mensuration. So we have done area of circle, and from the circle parts related to it. The first was sector and the second was sec. We have done questions related to this already, sector. If you remember, sector is what it looks like this portion right here that was called sector. Right. If you haven't attended the class, you look at the previous YouTube videos that has already been uploaded. And the segment is this part, right? This part right here. This part, the red part is the segment. We have finished questions related to sector, segment, and everything that is related to circle already. Now this circle, this is a plane figure. That means these are diagrams that can be drawn on a piece of paper, right? So these are plane figures. Now we are going to learn about shapes. We are going to learn about shapes which are in 3 dimensions. Shapes in 3 dimensions. Okay, shapes that you are able to see in your surroundings. So first of all, I'm going to give the introduction of to this portion of your mensuration chapter with sphere. First one, we are going to learn sphere. Sphere is a circle, but in a 3-dimensional space. Circle, we can draw it in a plain piece of paper, right? But the sphere, it is a 3-dimensional thing. What is a sphere? What is the shape of a sphere? The shape of a ball. Shape of a ball. The ball is a sphere. So whatever concerning sphere and whatever concerns circle, the most important thing that you need to understand is, the most important parameter you need to know is the radius itself. The radius was important in terms of circle, and the radius was important in terms of sphere also. Only thing, all right, the only parameter you need to be worried about is what is the radius, right? Radius is the distance from center to the surface of the sphere. Now, we are not calling this circumference anymore. Okay, for sphere, we are going to learn 2 things. First one is surface area. And second one is the volume. You know what is the surface area, right? If you take a bowl, then how much area does the surface occupies? Not this area, all right, not this area. This is a circle, so this area doesn't exist anymore. How much does the surface of the bowl occupies? How much is the area of the surface? That is called the surface area. The surface area, it will have a specific formula, and the formula will be 4 pi r square. So here, you know the its radius. And regarding the volume, I don't think I need to explain what volume is, right? Because you have already learned this in class 8, 9. And regarding volume, the volume is it's given by 4 by 3 pi r cube. The only difference is one is 4 pi, other one is 4 by 3. In terms of surface area, there is a square. In terms of volume, there is a cube. Okay. Okay, these are easy actually. The surface area of the sphere and the volume are easy. But cut it in half. Cut the sphere into half. You have a sphere right here. You cut it into half. Then the two similar parts that you are able to obtain from a sphere, they are called hemispheres. Hemispheres. These are half of a sphere, right? So we will call them as hemispheres. So if I draw a hemisphere, it will look like this. It will look like this. This is a hemisphere. Let's draw it properly. All right. Okay, there is a little bit of a break there. Hey. Who is turning on the microphone? Turn it off. Okay, There is a problem with my screen. I don't know. Okay, let's check. Yeah. Wait a minute. Okay. There is a problem with my screen. Cannot write here anymore. Some portion seems to be wet. Let's check. Okay, now. So this is a hemisphere. It's not very perfect, but it is half of a sphere, right? So for this half of a sphere, you know that the distance from here to here is also r. The radius itself, center to one part of the sphere, it will be the radius. The distance from here to here, it will also be r. So you have to note this down because we are going to use this for in numerous questions. The distance from here to here is also the radius r. The distance from here to here will also be the radius r. Let's name this O, this is A, this is B. Since it's a sphere, OA is equal to OB. This is equal to radius r. Now, coming to the volume. Volume is the capacity of the sphere, right? How much things does the object that is making the sphere contains? That is the volume. So volume has 4 by 3 pi r cube in it for a sphere. If we make the sphere a little smaller, if we cut the sphere into half, we get a hemisphere, as you just have seen. So in a hemisphere, what will happen to the volume? The volume used to be 4 by 3 pi r cube. So the original volume looked like this, 4 by 3 pi r cube. For a hemisphere, you have to cut it into half. That means you have to divide it into 2 parts, right? So when you cut the 2 and 4, 2 2s are 4, the remaining will be 2 by 3 pi r cube. This is the volume of a hemisphere. So for a sphere, it's 4 by 3 pi r cube. For a hemisphere, the volume is 2 by 3 pi r cube. So you have to note this down. And you have to understand how the 2 by 3 instead of 4 by 3 come into being. Okay. Okay. Next one, coming to the surface area. Coming to the surface area. Okay. The surface area, will we cut this into half? The original surface area of the whole sphere is 4 pi r square. For a hemisphere, that means for half of a circle, will we divide this by 2? Yes and no, depends on what type of sphere it is. Okay, if it is solid, if the sphere is filled with something, let's say the sphere is made of plastic and the plastic is filled inside the whole thing, there is no hollow space inside the sphere. In that case, there will be a surface here. Look, this portion will still have a surface. It won't be hollow when you cut it into half, right? And if it was hollow, if there was nothing inside, when you cut it off, when you cut the sphere into half, what we are going to obtain, it will look like this. There will be nothing in this space right here, nothing here, if the sphere is hollow. You know the meaning of hollow, right? If the inside is filled with nothing. If the inside is solid, there will be a space here. You will see a surface area here. What's the shape of this? This is shaped as a circle, right? So the surface area, it depends on whether the sphere is hollow or solid. So we have two cases here for surface area. For a hollow sphere, hollow hemisphere, we're talking about only half the sphere. The surface area of sphere was 4 pi r square. For a hemisphere, we just have to divide this by 2. Let me just write down as SA, which will indicate the surface area. 4 pi r square will be divided by 2, and we will have twice pi r square. Second condition, if we have a solid hemisphere, for a solid hemisphere, this portion will still exist. 2 pi r square will still be there. Surface area will be twice pi r square. The twice pi r square portion is this portion right here. Okay, this portion right here. You take a ball and the surface where the plastic is, that portion is the surface area. But in case this is not hollow, if this is solid, then there will be a surface here, an extra surface, extra portion of the surface, and which is shaped in the form of a circle. So this circle part will be added. This circle part will be added. What is the area of the circle? Area of the circle is pi r square. So here is 2, here is 1, and there is pi r square in both of them. So the total surface area of the hemisphere will be how much? 3 pi r square. So remember, when we cut off the sphere into half, the volume will be 2 by 3 pi r cube. This is irrespective of whether the sphere is hollow or solid. Okay, if it is hollow, then this volume will apply. If this is solid, if the inside is filled with something, then this formula is still valid. You just have to know the radius. But coming to surface area, we have to differentiate into two parts, hollow and solid. For hollow, the surface area is twice pi r square. For solid, the surface area will be 3 pi r square. Okay, you draw these two figures and you have to copy these two parts also. This is this portion here, it will indicate the formula, the necessary formulas that we are going to use in the coming exercise 12.4. And remember 12.3, we have skipped it. I've been saying it numerous times. 12.3 is out of your syllabus. Moving on. Hemisphere and the sphere is done. Okay, next part. For the next shape, we have to learn three shapes actually. First one is the sphere. Second, we have to learn the cylinder. Third, we have to learn the cone. So sphere is done. Let's come to the cylindrical portion. Okay, I don't think I need to explain what a cylinder is. So you all know what a cylinder looks like. Let me just draw a basic shape. So this is a cylinder, right? So for a cylinder, you need to know two parameters, two values. The type of cylinder we are going to learn is a right circular cylinder. So right circular cylinder, okay. So here it mentions something here, the word right. That means there must be a 90 degree somewhere. The 90 degree is here. So we have a top and a bottom. These two parts, they are shaped like circles, right? If you look from the top of a cylinder or bottom of a cylinder, you will see a circle on the top and bottom. So this circle, they should have a radius, isn't it? So they have a radius. This one also, they have a radius. If you join the two centers like this, then this center line, this is called the axis, and these are radius. This is radius. This is also radius. So for a right circular cylinder, the radius and the axis, they should be perpendicular to each other. If that happens, then we will call the cylinder as right circular cylinder. We can draw another type, right? The cylinder can still look like this. Here will be your axis, but look, the radius of the top and the axis, they are not perpendicular to each other. It is not 90 degree. So in that case, this type of cylinder, we cannot call it as right circular cylinder. So right circular cylinder, it is a specific shape in which the radius of the circle on the top and bottom, it should be perpendicular to the axis. So for right circular cylinder, volume, this is called the height, right? Distance from here to here, this is called as the height. We are going to represent it with h. And the radius of the top and the bottom. So this part right here, this is the radius, which will be represented by r. At the bottom also, it's the same thing. It's the radius r. So for the volume, what's the formula? The formula is pi r square h. What about the surface area? Okay, surface area, it will depend on two conditions like we have done in the case of a sphere. If it is a hollow thing, right, take the example of a cylindrical glass, right? For a cylindrical glass, let's say the top and the bottom are hollow. Then there won't be a circle here, there won't be a circle here. And this portion right here, the shaded portion right here, in all direction, okay? Wait a minute, the drill has started. So this portion right here, the area of this portion right here, you take your glass and the portion where the glass is staying, the area of that portion, that is called as what? That is called as curved surface area. Okay. So when we come to the surface area of a right circular cylinder, we will have two types. First one is curved surface area. This curved surface area, it will be given by twice pi RH. So R indicates the radius and H indicates the height of the cylinder, right? And you should understand what a curved surface area is. Let me just shed this portion right here. In all direction, okay, I'm showing just one side of the glass or one side of the cylinder. So when you take this portion in all direction, that portion is called as the curved surface area. And you should know the formula, it's 2 pi RH. And second condition, if we have the top and the bottom, in a water glass, it is sure that there is a bottom, right? There is glass in this portion here also, isn't it? And if it's a solid glass, then we will have a top also. What are the shapes of the top and the bottom? Top is a circle which will have an area pi r square. The bottom has also a surface area which will have pi r square since it is shaped as a circle. So if the cylinder that we are taking, it is uh, a solid glass or it is a solid shape, then we have to include the top and bottom. When we include the top and bottom, we will have a pi r square from here, another pi r square from here. How much is the total? Twice pi r square. So in this curved surface area, if the cylinder is solid, we will have to add another twice pi r square. If 2 pi RH and 2 pi r square are added, it won't be called curved surface area anymore. But the curve will be replaced by total. It will be total surface area. So the formula for total surface area, it will look like this. Total surface area. This is equal to twice pi RH. From here, you have to add a pi r square and a pi r square. This is the area of the bottom. This is the area of the top. Okay. So these two pi r square and pi r square, it will give you twice pi r square. What can be taken out as common? 2 pi r. We can take out as common. So twice pi r from the first one. What is remaining then? If I take out this, and this, h is remaining. So we will have h plus 2 is taken away. Pi is also taken away. One of the r is also taken away. That means there will be n r remaining, right? So this is for total surface area. This is for curved surface area. Curved surface area is the part that where I'm shading. Actually, it's not supposed to include this portion, right? Okay, whatever. So copy this one also. Surface area and total surface area. Volume, you have known this one. You have to add something here. This is perpendicular, this is perpendicular. Okay. In this part, you have to show that the radius and the axis are perpendicular. You have to show this in your figure. 90 degree here, 90 degree here. Let's try to take up 1-2 question from the exercise after we finish the cone. Okay. Unless we finish the cone, we will not be able to start anything else. Okay. Is it done? Finish copying?
Yes, sir.
Yes, sir.
Everyone?
Yes, sir.
Okay then. Moving on. So next we are going to come into a right circular cone. Okay, not just cone, but right circular cone. We will have a similar property there also. Okay. So I'm rubbing off all of this. So here this is the shape of a cone. You all know this is the shape of a cone. And this top is called as apex or vertex. Okay, the top of the cone we will call it as apex or vertex. From the top, from the apex, if you draw a line to the center of the circle, this line is called axis of the cone, and this is also called height of the cone. So this length here, the length of this portion, it will indicate the height of the cone. Height of the cone, this will be represented by h. Let's name it as h. And the radius, let's put r as its symbol. So for a cone, you should know that a cone is 1/3 of a cylinder of the same height. Okay, if you have a cylinder like this, and from the same thing, if you draw a cone like this, then the cone portion is 1/3 the portion of the cylinder. What was the volume of the cylinder? Pi r square h, right? So for a cone, we have to multiply here by 1/3 because it says it's 1/3 of the volume of the cylinder. So when we come to right circular cone, you need to understand the meaning why there is a right mentioned here. For this right circular cone, what you have to have is the radius and the axis. These two should be perpendicular. Okay, so these two should be perpendicular right here. That's why it says the word right. If you have a cone like this is still a cone, but the radius and center, they will not be perpendicular. Okay, in that case, we are not going to call it a right circular cone. So for a right circular cone, the volume will be how much? 1/3 pi r square h. Curved surface area will be pi r l. Total surface area will be how much? We will have pi r l plus pi r square. Pi r is taken common factor, there will be l plus r. And one more thing you need to understand here is, this is the radius, this is the height, this is the radius. This portion right here, the length of this portion right here, we will call it as slant height. You need to understand this also. This is the slant height. Okay, there is a certain relation. The slant height will be represented by L. Okay, so this is H, this is R, this is L. R, H, and this is L. Okay, so let me just show you in the diagram itself. This is H, this is R, and this is the slant height H, slant height L. So for these three, L, H, and R, what's the relation? This is a right angle triangle in itself, right? This is a right angle triangle. That means we can apply the Pythagoras theorem. So what will be the Pythagoras theorem? This is the hypotenuse. Hypotenuse, perpendicular, radius. So by Pythagoras theorem, what we are going to have is L square is equal to R square plus H square. You can find out L. You can find out L like this: root over R square plus H square. You can find out R. If you take H, this H square to the other side, we will have R square is equal to L square minus H square. If you find out R, it will be L square minus H square. Similarly, you can find out H also, but most important thing is how to find out the value of L. Okay, so you have to mention here what is H. R is the radius, H is the height, L we will call it as slant height. If you don't copy this to, at least copy this portion. Okay, copy this. Let's try to start one question from the exercise. You have to have this formula on the side also. So I'm taking up a question from your exercise, question number 2. What we are going to do is we are going to find out the volume, surface area of a combination of figure. Okay. Here, one of the most frequently used word will be surmounted. Surmounted means one is put on top of the other. If a cone is surmounted on top of a hemisphere, it will look like this. This is a hemisphere. On top, we are just putting a cone like this. So this is a cones are mounted on top of a hemisphere. We will have questions related to this, but first of all, let's focus on question number 2. Okay, it says a solid is in the form of a cylinder of diameter 7 centimeter with hemispherical ends. Hemisphere, what does it look like? Hemisphere look like this, right? Or like this, half of a sphere. So solid is in the form of a cylinder. You draw a cylinder first, and then on the top you put hemispheres. So hemisphere on the top, hemisphere on the bottom. And the question says, if the total length of the solid, total length will be here, from the red part, this is the top, this is the bottom part. So top to bottom, this is the length. How much is it? This is 42. What are given? A solid is in the form of a cylinder of diameter 7. The radius of the cylinder is not given, but instead it is given the diameter here. The diameter is given, diameter is 7 centimeter. The question wants what? Find the total surface area and volume of the solid. Total surface area and the volume. So what are given first? Let's write them down. Given radius. So diameter of the cylinder is given. It's given as 7 centimeter. There is no use for us to do with diameter, right? We don't want diameter. When it comes to sphere, what we need is the radius. When it comes to cylinder, we need to know the radius and we also need to know the height, right? Okay, so let's name a few things here. Let's name it A here, B here, C here, and D here. Okay. Now look, diameter of the cylinder is 7 centimeter. We don't want the diameter. What we want is we want the radius. So say here, radius of the cylinder is equal to 7 divided by 2. Radius is diameter divided by 2, right? Okay, now we have got the radius. For the sphere, the radius is enough, right? But what about this portion right here? What about the cylindrical portion? For the cylindrical portion, we need the height also. So height is from where to where? Height of the cylinder is from here to here. B to C. B to C, the highlighted portion, focus here. B to C, we want B to C. But B to C is not given. What is given is the total length is given. The total length is A to D. A to D is given. What we want is we want the height of the cylinder, which is B to C. How to find out B to C? How much is AB actually? When I draw a hemisphere, I just told you in the beginning of this today's class, this is equal to this, right? If this is 7 centimeter, this will also be 7. If this is 5, this is also be 5. How much is this portion then? The radius of the hemisphere. It's 7 by 2, right? This is also 7 by 2. This portion, the highlighted portion, this is 7 by 2 here. This is 7 by 2 here. That means this portion right here, the vertical part, this portion will also be 7 by 2. This portion will again be 7 by 2. So this is 7 by 2 and this is also 7 by 2. So AB is 7 by 2. CD is also... What is it? What happened? So CD is 7 by 2. AB is also 7 by 2. We want BC. Total is 42. The end parts are known. So from the 42, if I cut off the 7 by 2, this portion right here, and if I cut off the CD, which is 7 by 2, we will get this portion BC, right? So you mention here height of the cylinder. It will be what? BC. How to find out BC? From AD is the total. From AD, we are subtracting AB and CD. AD is 42, AB is 7 by 2, CD is also 7 by 2. These two are of the same sign, both of them are negative. 7 by 2 and 7 by 2, how much is it? This is 7. 14 divided by 2 is 7. 7 by 2 plus 7 by 2 will be 7. So if you add these two, we are going to get 7. What's the final value? 35 centimeter. So everything regarding the cylinder is known, right? Radius of the cylinder is known, height of the cylinder is known. What about the hemispheres then? For the hemispheres, we just need the radius, right? Radius is, it will be the same as that of the cylinder because one is on top of the other. The radius of this will be same as radius of this. Radius of cylinder and the hemisphere, they are the same. So for hemisphere, the radius will be how much? It will be 7 by 2. Now, time to find out what the question is asking. The question asks, find the total surface area and the volume. Okay, let's start with the volume. The shape consists of three parts: cylinder part, hemisphere part, hemisphere part. So there is a cylinder, there is a hemisphere, there is a hemisphere. So if we add the volume of all the three, 1, 2, 3, we are going to get the total volume, right? So total volume. What is the volume of the hemisphere? The first one. Volume of the hemisphere, we have just learned it's 2 by 3 pi r cube. What about the second hemisphere? This portion right here is 2 by 3 pi r cube. What about this portion? It will be the same, right? We have to add another 2 by 3 pi r cube. So this part is done. This part is here. This part is here. What about the middle portion? The cylindrical portion. What's the area of the cylindrical portion? Volume of the cylindrical portion. It will be pi r square h. Now these two are the same, right? 2 by 3, 2 by 3. If you add 2 by 3 and 2 by 3, how much is it? It's 4 by 3, isn't it? So 2 by 3 plus 2 by 3, it will be 4 by 3 pi r cube plus pi r square h. Remember, we are not putting the value yet. We will take common factor and we are going to put in the value at last. What can be taken as common factor between these two? Pi can be taken as common factor, right? Pi is taken as common factor. R square and R cube. You have to take the smaller one. Smaller one will be R square. So you take R square common factor outside. What is remaining? There is 4 by 3 remaining. Pi is gone. So put the 4 by 3 in here. Pi is gone. Out of the R cube, R square is taken away. That means 1 R should be remaining. Finally, pi taken away, R square taken away. That means H is left. Put H here. Okay, now time to put in the value. Pi is 22 by 7. R is 7 by 2 into 7 by 2. Okay, this portion is fulfilled. Pi is here. R is here. Another R is here. Let's come to the bracketed portion. 4 by 3. And here is an R. Instead of R, we are going to put 7 by 2 plus. Instead of H, what is the value of H? The value of H is here, height of the cylinder. R is the radius, height of the cylinder is here, 35. So put the 35. Okay, copy up to here. We will do the calculation later on. This type of question is slightly complex, so I encourage you all to ask as many questions as possible. Once you don't digest one question, it will be problematic for the rest. So ask as many questions as possible, right? Okay, let me do just small cancellation. 7 and 7, 2 and 22. The rest cannot be, the rest we have to leave it. And one cancellation here, 2 2s are 4. Let me just rub off until here, okay? Let's just finish this calculation. Let me rub off up to here. I'm coming from here to here. All right, here. So whatever is left, you keep it. There is a 11 left, 7 by 2 left, and there is 2 left above, 7 left, 3 left plus 35. So we have 11 into 7, it will be 77 by 2. Then 14 by 3 plus 35. So we have 77 by 2, and if you add these two together, we will have 3 here, 14 plus 14 plus 3 into 35. So we have 77 by 2. I'm rubbing this part off also. So 5s are 15, 3 3s are 9, 105 plus 14 divided by 3. 77 by 2 into 119 by 3. So finally we have 6 as the denominator. 119 into 7. We will have 3, 6, 1, 8. Okay, final value, you calculate this. 8163 divided by 6, right? Continue copying, okay? It's just multiplication, division, show. No big issue there. It's supposed to be 9. Sorry. I haven't put in 1 carry. So the final answer is 1527.16. We're finding out the volume, so you put centimeter cube. Okay, after copying, you come to this. Okay, the surface area here, look, we have found out this portion only. The total surface area is slightly longer than this. So better if we continue tomorrow. And we will pick up some more questions from your exercise 10.4. This is exercise 10.4. So just mention here exercise 10.4. Okay, let's stop here. This portion I'm going to teach it tomorrow. Total surface area. We will have to take the surface area of this part, and we will add them all together. And one of the hints that I want to give you all is don't just put in the value directly. Okay, you can find out the surface area of this separately. You can add them together, but that will take longer time than what we are doing right now. So the better way is you write the formula for everything else, like I just have done. You write the formula for everything else, and you take common factor. After taking common factor, we are left with this, right? And when you have the complete formula, you put in the value of RRH. That's it. That way, finding out the volume or the surface area, it will be shorter and simpler. The only part that will consume time is the calculation part. The others, it won't take much time. But if you are able to do up to here, then I'm sure if the question is 3 marks, you will be given 2 marks for sure. This portion, it will carry just 1 mark. Okay, okay then. I'll see you all tomorrow.